Welcome to the first introductory video lecture in this compilers course. My name is Anoop Sarkar. I'm going to be the instructor of this course. Each of these video lectures categorized by a prefix. So this one is called IN1 because it's the first video lecture in the intro week of this course. This first video lecture is a high-level motivation for what we're going to do in this course and why you should take a compilers course as an undergraduate. The arguments first laid out in this blog post by Steve Yegi, at the time was a developer at Google. Blog post was quite some time ago in 2007 called Rich Programmer Food, in which he tries to make a case for why you should take a compilers course. The first thing he says is if you don't know how compilers work, then you don't know how computers work. Now this phrase, how computers work, is a little bit vague, and so we'll go into more details with some examples about what exactly he means by how computers work. At a high level, I think he means that you need to know how programming languages work because everything is written in a programming language, especially in a high-level programming language nowadays. Nobody sits down and writes an operating system in assembly language anymore. If you don't know how compilers work, then you don't know how code is compiled to create almost anything that is at the systems level. If you're not 100% sure whether you know how compilers work, then you definitely don't know how they work. You can't do a lot of programming and kind of figure it out. So you need to know exactly how compilers work to understand how programming languages work from the inside out. In fact, Steve goes on to say, compiler construction is, in his own humble and probably embarrassingly wrong opinion, the second most important CS class you can take in an undergraduate computer science program. That's his opinion. I think the same as well. Compilers was one of my favorite courses when I was an undergrad. It's one of the reasons why I like teaching compilers, because it's an interesting, if challenging, course both to teach and to take. Steve goes on to say, I'm not saying that other CS courses aren't important. Incidentally, operating systems, machine learning, distributed computing, and algorithm design are all arguably just as important as compiler construction, except that you can take them all and still not know how computers work. This is, again, kind of interesting what he means by how computers work. Obviously, if you take an operating systems course, there is a lot in there about how a modern computer manages all of the hardware and offers it as a system that people can use. But an operating system is itself written in a programming language, and so an operating system has to be compiled. So if you look at what is fundamental, you really need a compiler in order to build an operating system. So what will you learn in this course? The first part of the course will go through lexing or lexical analysis, which is recognizing the tokens in a programming language. Subsequent to that, we're going to do parsing, which is syntactic analysis, which is trying to understand the structure of the program, decomposing it into its subparts so that we can easily process the different parts of the program. Because you can't do it as a whole, you need to do it essentially by breaking it down into smaller parts. Then we look at type analysis, which are all the constraints on using the language, because not everything that is syntactically correct is going to lead to valid code. Finally, we're going to do code generation and optimization, which generates from a high-level programming language something that can actually run on the computer, generates the bits that are needed to be loaded into the hardware and run. So if you look at these four stages, the first stage of lexical analysis is very similar to the notion of letters and words in natural language. They're the basic building blocks. You need to start from knowing what the letters are, composing them to get words. Once you have words, you can put them together to form sentences. Not all sentences will be grammatical. In the same way, you need to understand how in a programming language there are valid programs and invalid programs. Type analysis is very similar to semantics in natural language, where you can't just sort of say that a sentence is grammatical, therefore it's meaningful. Famous sentence from Chomsky is colorless green ideas sleep furiously, which is grammatically valid, semantically doesn't seem to mean anything. And finally, code generation and optimization is similar to how language maps to the real world. So in this case, we're generating code, which is assembly language, take the assembly language and convert it into a binary. That's kind of the mapping of this high-level programming language to the real world of the computer. So in his blog post, Steve Yegi he also talks about how even if you're not going to write a compiler, learning all of the tools that you learn in a compiler course can be useful. So for example, he gives you several situations where knowing compilers can help you do tasks that don't seem like writing a compiler for a programming language. So the first situation he talks about is how do you auto-format source code of a Java library with like a lot of lines of code, like more than 1 million, and someone in your company that you're employed at has come up with these formatting guidelines that are not standard. So you need to auto-format the source code of everybody's submissions to this Java library in your company and make sure it's obeying these formatting guidelines. Well, it's not going to be feasible to do it by hand, and you can't just hack it. You could try to do that, but you'll often run into problems because your ad hoc solution is too hacky. It turns out that using some technology that we'll study, it becomes fairly easy to write a provably correct way to auto-format the source code by knowing about the structure of the Java programming language. And this is not specific to Java, of course. It could be any programming language. Situation 2 is your company decides to do automatic documentation extraction from JavaScript code. Your task is to write a JSDoc extractor. Again, you could write some arbitrary code that tries to extract it out of the programs. You probably will run into bugs because it's ad hoc and hacky solution. What we want is a solution that is guaranteed to work on any code that anybody will write in the future. So how do we do that? Compiler tools actually do help you do that. Another situation is refactoring a massive code base in C++ in some non-trivial way. For example, going from 32-bit to 64-bit, it turns out is not a trivial task. So again, you really need to transform C++ code, take it as input, produce a new output C++ code that obeys certain criteria. Compiler tools can help you do this in a provably correct way. In situation 4 is you're given the task of writing a syntax highlighter for a web tool that deals with a large number of programming languages. Now, you could write a tool that deals with one programming language, hard coding all the rules for that language. What you really want is something that will take the specification of the programming language and do the syntax highlighting based on what's a reserved word, what is a while loop, what is a for loop, what are functions, what are classes, etc. Not doing it for one programming language is the key here. You have to do it for all of them, no matter what they are, as long as you have a specification for them. Situation 5 seems like a low level of systems you think. You need to communicate with the new router that has a telnet interface and a proprietary command language. It's not uncommon, and different companies will have completely different such command languages. So you need to understand these responses, parse them, and produce new commands to interact with this router. So again, this doesn't feel like writing a compiler, but all of the tools that we will study in this compiler course will enable you to write such a tool using fairly general principles so that you know it's correct and it's not a hack. Another situation 6 in Steve's blog post is the software engineers, quote unquote, at your company have decided to redesign the entire code base to make it easier to add to the code base. Now you have to write them a tool to ensure code maintenance does not get worse. This is not a hypothetical. So a large company like Google, for example, they often have a style guide for C++ that they want to enforce on all of their programmers so that people don't check into the code base code that's hard to maintain. One way to do that is make sure that the compiler itself knows about these requirements. These requirements as well can help you redesign the code base by mapping code in one form to another. So this kind of translation is something that compiler tools are very good at. Write it in a way that's not ad hoc or hacky. Situation 7 in Steve's post is, in order to remove a security hole, you must make a set of non-trivial changes to the code to replace one idiom. So an idiom is just a bunch of statements together. Sometimes the security advisory says, well, if you do these two statements together, then there's a security hole that can expose your system to a malicious hacker. So you want to make these changes to the code to replace an idiom series of statements with a different series of statements that doesn't have the same security hole. So if you haven't already, I would recommend you look up what a CVE is. And a CVE is something that is announced to the community, the worldwide programming community, to say these are security holes that you should avoid. It's often very tedious to go through and change a large code base based on a new CVE. So So it's really useful to have something that can do this automatically. The next thing I want to talk about is what you will learn in a compiler's course is also a inside-out knowledge of how programming languages work. In order to talk about this, I'm using an example here to answer this question for yourself. Do you really know how programming languages work? So here's as an example C program. It's a very simple C program. It's got essentially 2 lines of code. So there's 1, 2. This function is called send. It takes 2 arrays, an array called 2 and an array called from and a count. And what it's doing is the variable 2 contains a pointer. So often pointers are written in hex, so I'm just going to do that. So let's say that 2 has the value 0x0ff. So at some point in the memory, somewhere in memory, there is 0x0ff. And this is the first. So if this is my memory, then 2 is pointing to this position over here. And let's say that from is a different memory location, fff. So what it's going to do is it's going to take each element from this location over here and then copy it over to this location. And then it's going to increment the pointer from and to the next one, and then take this location and copy it over to this one, and so on. And it's going to do this count number of times. So you need to tell it how many of these that you need to copy. So if you know, so by the way, I assume that you know C and C++ in enough detail that this piece of code is going to be easy for you to understand. If this code, pointers and so on, are concepts that are not entirely mastered, then this course is going to be very, very challenging for you. So this function send, you should know, is very similar to the memcopy system function that you can use in C. It's just a very similar function that copies from one location to the other. Obviously, you understand this function. This is a very straightforward function, and you should understand this function inside out. There's no excuse not to understand this function. Now let's see if we can take this function and change it and see if you still understand it. So let's take this function send, change it into a new function called send2. Send2 is seemingly doing the same thing as send. It's supposed to be doing the same thing, but instead of 2 lines of code, there are 10 lines of code. It's still copying, as you can see from here, copying from one location to another. So it's doing roughly the same thing. You can see it has 8 of them. So clearly it has something to do with loop unrolling, right? Instead of copying one at a time, it's copying 8 of them at a time. So that much is clear, and you can see that it's this magic number 8 here is similar to this, or matches, not similar to, matches this number 8 here. So 8 copies here, there's a number 8 over here. So clearly there's some loop unrolling going on. But you can see this code should make you a bit uncomfortable because there's a while loop here, which is inside a switch statement that contains a while in it. But if you look at where this while begins is this curly brace, and this ends over here. But you can see that there's a bunch of these case statements somehow inside this while loop. So that's a bit odd. It looks like someone is playing fast and loose with C syntax, and who knows, maybe this function is just going to give you a syntax error. Your task is to look at this, answer a couple of questions. So you want to compare send and send2. The first question is, if you look at send2, is this valid C syntax? Is send2 a valid C program? There are many ways to check this. The easiest way is you type it out and see if it compiles. The second question is, why would someone do this? Why would you take 2 lines of code and write it down as 10 lines of code? You can see there's something to do with loop unrolling, but why write it in this particular way? I want you to think about these 2 questions. And with many of my video lectures, what's going to happen is there will be some extra slides that are not covered inside the video lecture, but I expect you to read them. The slides will be available online on the course webpage. So I would expect you to read the extra slides and come up with answers to these questions, and we'll discuss them later. So why should you take compilers? You really want to understand programming languages, how they work from the inside out, you have to take a compilers course. There's no substitute for this. If you want to design and build your own programming language, and there are many, many reasons why you want to design design and build your own programming language. It's not just general purpose programming languages, but also you can write a programming language for video games, for AI, for robotics, security. How about a language that deals with GPUs now that they're so common and commonly used for lots of different applications, including machine learning. Concurrency, so dealing with 60 cores, maybe a programming language that makes it easy to deal with concurrency is something that you're interested in. Well, if you want to build a compiler for your new programming language, you need to take a compilers course, obviously. All modern web browsers have compiler technology buried deep within them, and in order to make them fast and responsive, there's a lot of work going on in compilers inside a web browser. The most commonly used programming language in the world now is JavaScript, a compiler that even gives you a small speed advantage, and JavaScript programs can make a huge difference in the amount of energy we use, the amount of time people spend executing the JavaScript code. Why should you take compilers? Well, you can write tools that can transform programs into other programs. So this is quite often something, so a lot of the situations that I mentioned earlier from Steve Yeggie's post fall into this category. And you will see that by learning compilers, learning those tools, you can reach for those tools and do a much faster job at implementing something complex that takes input programs and produces output programs. Compilers also is the best place that you can understand parsing algorithms. Take any text input and then transform it into tree structures. And the reason why you want to take text and convert it into trees, it allows you to divide and conquer this large piece of text into subparts, and then you can deal with each subpart independently and apply sort of divide and conquer algorithms to it. And compilers obviously is the main place where you understand code generation and code optimization. Any compilers course should be a place where you can learn compiler tools. So they're tools that we will be using to build a compiler. And the goal of this course is to have you build a working compiler. So you can't take a compilers course without building a compiler, which is why it's such a challenging course. And we are going to be using tools like Lex. As you can tell from the name, Lex is something where you do lexical analysis with it. Yak, I'll explain what that is, but it's kind of a tool that helps you write parsing algorithms very quickly for new programming languages. And finally, LLVM, which is a tool for code generation and code optimization, and it's one of the de facto tools that people use for all kinds of things in compiler related tool writing. So LLVM is an important library, and it's something that we'll be using, and you'll get a detailed background in this, which is going to benefit you in many different applications in the future. I'm going to stop here. Like I said before, I expect you to go through these slides by looking at them. The PDF of the slides are available on the course webpage, and it'll cover some of the questions that I've raised in this video lecture, and we can discuss it later.